Now we're going to do another problem. We're going to do 4 2/5 multiplied by 7 3/4. We're going to draw an area model. So we don't forget any of the pieces. And while we do this one, I want us to think what we think the procedure for this will be. On all of them, we've had a procedure, meaning just the math. What do you think that just the math would look like for these problems? So we're going to break this up into expanded form, the whole and the parts. We're going to put 4 2/5 across the top. And then we're going to put 7 3/4 down here. And that's not what I have written, but it's fine because I can do math. Okay, then we're going to write the small problems in the boxes. We have 7 times 4. We have 4 times 3/4. We have 7 times 2/5. And we have 3/4 times 2/5. Now I want us to think what is going to go into each box. Inside each problem, or inside each box, we're going to put the product of each problem. And we know how to multiply a whole number times a whole number times a fraction, and a fraction times a fraction. So 7 times 4 is 28. Then we go 7 times 2/5. Well, we observe and we recognize that 5 does not go into 7 evenly. Therefore, whatever number we get here, it is not going to be a whole number. So we're going to turn this into 7/1. And we're going to go 7 times 2 is 14. 1 times 5 is 5. We observe that this is an improper fraction, so we are going to convert it to a mixed number. And we think, how many times can 5 go into 14? We go 5, 10, 15. Oops, 15 is too much, so that is 2. 2 times 5 is 10. 14 minus 10 is 4 all over 5. Then we come over here and we observe that 4 can go into 4 evenly, which means that whatever answer we get here is going to be a whole number. Because remember, when our denominator goes into our whole number evenly when we're multiplying fractions times whole numbers, our answer is going to be a whole number. So we're going to go 3 times 4 is 12. 1 times 4 is 4. We observe that that's an improper fraction. So we go, 4 can go into 12 how many times? 4, 8, 12. Ooh, we can stop. It goes in evenly how many times? 3. Then we come over here and we go 2 times 3 is 6. And we go 5 times 4 is 20. Unlike up here where we had to stop and we could have easily converted this into a half, we need to look here. How many fractions are we adding from these 4 boxes? We're only adding 2. If we simplified this, would we have to come all the way back up and find an equivalent fraction? Or would it help us? Well, let's look and think. What numbers go into 6? What are the factors? We have 1 times 6. We have 2 times 3. That's our baby rainbow. So we have 1, 2, 3, and 6. Which one of those numbers go in here? Does 6 go into 20 evenly? Does 3 go into 20 evenly? Does 2? So let's divide this by 2. 6 divided by 2 equals 20 divided by 2 equals 10. Is that something that we can still work with? That's its simplest form because 3 is a prime number and it doesn't go evenly into 10. So is that something that we can work with? I say yeah. So now we're going to pull all of those out and put them over here. We have 28 plus 3 plus 2 and 4/5 plus 3/10. Now we're going to stop and observe. Now that we've observed, we notice that this is an addition problem. We cannot add things that do not have the same denominator. So we know that we're going to be changing our denominator. Well, if we think about what we know about 5 and 10, 5 is a factor of 10, which means we can make an equivalent fraction with tenths. So that's what we're going to do. Also, it's the one that's in our fraction by fraction. So we're going to drop down our whole numbers, because you don't want to forget them. We're going to do something tenths plus, we're not going to change this, so we can just drop this one down as is. We come back up here and we think, what did we multiply 5 by to get 10? 2. Golden rule of fraction says whatever we do here, we have to do up here. What's 4 times 2? 8. Now we observe again. Can we solve this problem? We can. So we are going to add our like things, our whole numbers first. I'm going to add 2 plus 28, which is 30, plus 3 is, now I'm going to add my fractions. I'm going to just put down 10 and not 20, because we never, ever, ever add our denominators. That is another golden rule of fractions. So we go 8 plus 3, which is 11. Then we stop and we observe. What do we observe about this mixed number? What's wrong with this right here? It is a improper fraction, which means that we cannot leave our answer in a mixed number with an improper fraction. So we're going to have to convert this. The very first thing we're going to do is we're going to drop down our 33 so that we do not forget about it. Then we're going to convert this into a mixed number. We have to think, how many times does 10 go into 11? Let's skip count by tens. 10, 20, oops, that's too many. What's 10 times 1? 10. So it goes in 1 time. And then we go 11 minus 10, which is 1. And what do we observe about this? 1/10 is what kind of fraction? Which means that when we add it to our whole number, it's going to be in its simplest form. So we go 33 plus 1 and 1/10 equals 34 and 1 and 1/10. So that is how you multiply mixed numbers. Now that we did these two problems, what do we think the procedure is? What's the math look like? I want you to pause this video and think about it. So hopefully we're noticing that we're taking the products of all of these boxes, just like we did with our area model. And then we're doing what with all of them? But what are each one of these boxes, what do they represent? And what they represent is the whole number of the multiplicand times the whole number of the multiplier. The whole number, the whole number. The fraction of the multiplicand times the whole number of the multiplier. The fraction of the multiplicand times the whole number of the multiplier. The whole number of the multiplicand times the fraction of the multiplier. The whole number of the multiplicand times the fraction of the multiplier. And then the last thing we have is the fraction of the multiplicand times the fraction of the multiplier. What are we doing with all 4 of these products? What operation are we doing with them? Once we get all of these products, we are doing what? We are adding them up. So the procedure, you're going to write this at the bottom of your page with as much room as you can. The procedure is the whole number of the multiplicand times the whole number of the multiplier plus the fraction of the multiplicand times the whole number of the multiplier plus the whole number of the multiplicand times the fraction of the multiplier plus the fraction of the multiplicand times the fraction of the multiplier. What kind of problem is this that has multiple operations, parentheses, things that we have to do first? This is a problem where we use order of operations, which is called PEMDAS. So the procedure for this, it's very similar to the procedure when we multiply a whole number times a mixed number. Except now we have the fraction piece added on because our whole number now has a fraction with it. So this is the procedure. As you can see, there are 4 separate things that you have to remember to do. It is a lot simpler to put it in the area model because you can't forget stuff. So when you have it in the area model, you can't forget stuff. Also, it separates these from these because a common mistake with the area model is that I might multiply 5 times 3/4, and that's not, we can't do that because they're part of the same number. But when I have them like this and it's like Battleship, I can line everything up. So when you do multiply mixed number by mixed number, sure, you can do the procedure. But you want to make sure you don't forget anything, so that's why we do the area model, because it lays it all out and then we pull it all out and add it up.